Let us look at how we apply reduction formula for the integration of product of two trigonometric functions with powers. So we have integral cos nx sin mx dx. So here we will do a substitution. U is equal to cos to the power of px sin to the power of qx. Now, it is pretty similar to this itself, but later on I'll explain why we are going for this. So now we differentiate this. We get du by dx is equal to applying the chain rule. So p cos p minus 1x times minus sin x times sin qx plus cos px times q times sin to the power of q minus 1x times cos x. And then we simplify it. We get minus p cos to the power of p minus 1x times sin to the power of q plus 1x plus q times cos to the power of p plus 1x times sin to the power of q minus 1x. The first term remains as it is. In the second term, what we do is from cos to the power of p plus 1x, we take out cos square x, so that we end up with q times cos to the power of p minus 1x times cos square x times sin to the power of q minus 1x. This cos square x, we convert it into 1 minus sin square x. And then we distribute. We get q times cos to the power of p minus 1x times sin q minus 1x minus cos to the power of p minus 1x times q times sin square x times sin to the power of q minus 1x. Simplifying it further, we get sin to the power of q plus 1x. Okay, now like terms, we have minus p plus q, both are minus, so minus we take it out. So p plus q cos to the power of p minus 1x times sin to the power of q plus 1x plus q times cos to the power of p minus 1x times sin to the power of q minus 1x. Okay, we have reached this stage. Now we do a substitution. Let n equal to p minus 1, which implies that p is equal to n plus 1. And let m equal to q plus 1, which implies q is equal to m minus 1. So now what we have is u is equal to cos to the power of px times sin to the power of qx is equal to cos to the power of n plus 1x times sin to the power of m minus 1x. Now we integrate the derivative du by dx to get u. So which means we integrate the right hand side as well. So when we integrate, what do we get? Minus integral of minus p plus q, that is n plus 1 plus m minus 1 times cos to the power of n plus 1 minus 1 times sin to the power of m minus 1 plus 1. So we are basically substituting p and q with n plus 1 and m minus 1 plus m minus 1 times cos to the power of n plus 1 minus 1x times sin to the power of m minus 1 x dx. This integral and the derivative cancel out each other. So we are left with cos to the power of n plus 1x times sin to the power of m minus 1x is equal to integral of 1 gets cancelled. So minus n plus m times cos nx times sin mx plus m minus 1 times cos to the power of nx times sine to the power of m minus 2x dx. Now, we split this into two integrals and we take out the minus out of the first. So, minus integral of n plus m times cos nx times sin mx dx plus integral of m minus 1 times cos to the power of nx times sin to the power of m minus 2 x dx. Okay, m minus 1 also we could have taken it out, which is what we have done in the next step. Now here n plus m minus integral of n plus m cos nx sin mx dx, we take it to the left hand side, and cos to the power of n plus 1x times sine to the power of m minus 1x, we take it to the right hand side to end up with this. I'm sure you are able to see the pattern now. What we have now is cos to the power of n x times sine to the power of mx dx. We are taking n plus m to the other side is equal to minus 1 by n plus m times cos to the power of n plus 1x times sine to the power of m minus 1x plus m minus 1 divided by n plus m times the integral of cos nx times sine to the power of m minus 2 x dx. So here you will notice that the power of sine is getting reduced. So we have arrived at the formula for the integral of cos nx times sine mx dx. Now let's look at some cases. What if the sum of the powers is equal to 0? That is m plus n equal to 0. Now if you look at this formula, you will notice that n plus m is in the denominator. So it can't be 0. Not allowed since we are dividing by m plus n. Now, what if n is equal to 0? Then let's take this formula and substitute n with 0. So integral of cos 0x times sine mx dx is equal to minus 1 by 0 plus m times cos to the power of 0 plus 1 x times sine to the power of m minus 1 x plus m minus 1 divided by 0 plus m times the integral of cos 0 x times sine to the power of m minus 2 x dx. Okay, now this becomes 1. So we are left with integral of sine mx dx. And this we know in a previous session we have derived this is equal to, so the right hand side should be equal to what we arrived at previously. Minus 1 by m times cos x times sine to the power of m minus 1 x plus m minus 1 by m times the integral of sine to the power of m minus 2 x dx, because cos 0 x is 1. So this is the same formula that we had arrived at previously. What if m is equal to 0, but n is not? Then we get integral of cos nx times sine 0 x dx is equal to minus 1 by n plus 0 times cos to the power of n plus 1 x times sine 0 minus 1 x plus 0 minus 1 by n plus 0 times the integral of cos nx times sine to the power of 0 minus 2 x dx. Now simplifying this, we get integral of cos nx dx is equal to minus 1 by n times cos to the power of n plus 1 x times sine to the power of minus 1 x plus minus 1 by n times the integral of cos nx times sine to the power of minus 2 x dx. Now this is not very helpful, right? So what we do is, instead of n equal to p minus 1 and m is equal to q plus 1, we take n is equal to p plus 1 and m equal to q minus 1 to end up with a customized formula for this particular case. So here integral of cos nx times sin mx dx is equal to 1 by m plus n times sin x times cos n to the power of n minus 1 x plus n minus 1 by m plus n times the integral of cos to the power of n minus 2 x times sin to the power of mx dx. Okay, so here what is happening? Instead of sine getting reduced, the power of sine getting reduced, we are getting the power of cos getting reduced. So now let's apply this. Let's make m equal to 0. So we get integral of cos nx times sin 0 x dx is equal to 1 by 0 plus n times sin x times cos to the power of n minus 1 x plus n minus 1 by 0 plus n times the integral of cos to the power of n minus 2 x times sin 0 x dx. So sin disappears here. Sin disappears here. So simplifying that, we get integral of cos nx dx is equal to 1 by n times sin x times cos to the power of n minus 1 x plus n minus 1 by n times the integral of cos to the power of n minus 2 x dx. And this formula we have already seen in a previous session. We have derived it. Now remember, in the beginning we had integral of cos nx sin mx dx, and we had done the substitution u is equal to cos to the power of px times sin to the power of qx. Practically the same thing. Now the reason why we did that was so that it becomes easy to take care of m equal to 0 case by changing the substitution for p and q to n and m. So that was the primary reason. So what we have achieved is to figure out the integral of the product of two trigonometric functions, specifically sine and cos, with powers m and n using the reduction formula.